What to do if you have a three-phase motor current unbalance. If the current unbalance exceeds 10%, you must take action to avoid motor failure and further assets damage. To solve the problem, we need to find the unbalanced source, then to rectify. In our case, red line lead connected to U1. Yellow line lead connected to V1. Blue line lead connected to W1. Draw this table. On one side will be the three-line leads colors, red, yellow, and blue. On the other side the three motor leads, U1, V1 and W1. In between we will write down the current measurements. First phase draws 30 amp. Second phase draws 36 amp. Third phase draws 29 amp. So the unbalance is more than the 10%. Now, we will stop the motor and change the connection. Connect the red line lead to W1. Yellow line lead to U1. Blue line lead to V1. This to make the motor rotate in the same direction. Now, draw again the table, but this time according to the new connection. So it will be red, yellow and blue on the line leads side, but on the motor lead side it will be W1, U1 and V1. Now start the motor and measure the three-phase currents and write all down in our new table. If the high current and low current readings follow the same line leads, so the supply is the cause of the problem. If the source was causing the unbalance, that means we have a voltage unbalance which needs to be corrected. NEMA standard prescribes a 1% limit for voltage unbalance. Current unbalance can be expected to be 6 to 10 times the voltage unbalance on a percent basis. To correct the voltage unbalance, you need to measure the three-phase voltage at the motor side and the main substation side. If there was no unbalance at the substation side and the unbalance was found only at the motor side, that means you need to check U-cable and cable connection points, isolators, or breakers in between and connectors. If the voltage unbalance was also at the substation side, you need to check the load unbalance. Normally in three-phase systems, the single-phase loads, such as lighting, air conditioners, etc., all must be properly distributed between the three phases, to avoid increase the load on one phase. And load unbalance will lead to voltage unbalance. If the high and low readings follow the motor leads, so the motor is the source of the problem. If the motor is at fault, that means its winding turns per phase or per parallel circuit are probably not balanced, or the winding is misconnected. Measuring the lead-to-lead resistance with a digital low-resistance ohm meter may detect unequal turns. The lead-to-lead resistance should be within 2% of the average. If the resistive unbalance exceeds that limit, the motor may need to be rewound to correct the problem. Support us, subscribe now. Don't forget to like the video and share it with one of your friends who could find it helpful.